it's pretty exciting. It's something that I believe has been around a little bit, but 5G is only making it better. So without giving too much, let's get into introductions. So I'm Mark Indelicato, content marketing specialist. I'll be one of your hosts today. And then we've got Jacob Perry over here, our lead engineer on the side.
So we're just going to start off by talking about cloud computing. So we actually can't really talk about edge computing without first talking about cloud computing. So let's first just quickly go over what exactly that is. So cloud computing occurs when a device is performing computations using system resources that are not local to it. That's a lot of words for what it does. Basically, all it means is that the majority of the workload that your machine is doing isn't being done in the machine you're holding or maybe the machine that's sitting on your desk. Rather, it's being done in a data center offshore, maybe in California, maybe in New York, maybe overseas, who knows? And so we had to move to this model from kind of what was edge computing before, which we'll get into. So, of course, before we had large rooms full of computers, and with those, handled all of the computations right there on site. And then, of course, as we move forward in time, computers got smaller and smaller and smaller, and then we were able to have them in our homes. And then they kept getting smaller, and people kept wanting them smaller. And so as a result, we had to think of creative solutions for being able to cram so much power into the machine that you have in your pocket. And of course, we accomplished this with cloud computing. So rather than this small device that you have, such as an Alexa that's sitting on your table or your smartphone, it's not handling all of the computing power that you're asking it for, but rather is sending requests to large data centers and then having those requests fulfilled and sent back to them. And so this allows us to have virtually limitless power inside of anything that has any kind of interface, whether it be a screen, a speaker, pretty much anything that you can interact with. And of course, on top of that, we can't talk about IoT applications and things like that without talking about other systems that maybe don't have interfaces, that maybe don't have speakers, microphones, screens, but rather are small devices that take care of one task. And whenever we're trying to fit those in warehouses and things like that, we need more computing power elsewhere. And so cloud computing, as we've gotten into a little bit, has a lot of advantages. It was the solution for a really daunting problem, and a really good one at that. So first and foremost is cost savings. Not only are you saving an upfront cost by not having to build out huge server rooms, server racks, and other large pieces of equipment they're sitting on site like we used to have to do. Instead, you can just say, purchase Office 365, and all of a sudden your entire organization has a mail server that's very sophisticated and can do what it's supposed to do for a small monthly fee. The cost savings also go into that larger company, Microsoft in this scenario, where it's sort of, I like to think about it like buying in bulk at Costco versus buying individual things at a convenience store. You're always going to get more bang for your buck. So these companies can focus on building out huge data centers and buy large amounts of equipment for a little bit cheaper price and then loan it out to smaller companies. And therefore, in the works, everybody kind of gets to save money and everybody gets to make money in the process. It's a really great system. Of course, another thing that you get is security. If you have all of these data sets on site, if you have servers, if you have computers with sensitive information, maybe credit card numbers, maybe patient information, you're going to have a pretty robust security system on site to be able to protect from attacks from the outside. Whereas if you're using a cloud computing software, you can rest assured knowing that that larger company with that larger data center has all of the security needs that you could ever want, and probably more security than even you yourself could provide. for your own systems. And then, of course, mobility. I can take my laptop anywhere in the world and still be connected to the work I do every day personally. And this is accomplished purely through cloud computing. No matter where I am, I have my data, I have my tools, I have my computations that I need to run. Anything I need to do, I have it at the tip of my fingertips, because most applications these days run off of cloud computing. That's, I think, been one of the most fascinating learning curves about all of this, is learning just how many things depend on this process, and how many things depend on offshore data centers. And I feel like most people probably know that, but maybe don't realize how much of an impact it has on our daily life. So with any great solution, of course, comes a few disadvantages. So first and foremost, connectivity. If your data sets, if your computations are all being handled by a system somewhere else, if you don't have the ability to connect to them, then you've now lost your tools, unfortunately. On your data, you've now lost everything. And you haven't lost it, but if you're in a position where you don't have connectivity at that time, you can't actively work on it, which is unfortunate. So in an event where maybe you lose internet somewhere during a building or during an outage, which of course you can have failover in place to be able to negate that from happening. But in the event that you don't, you've now completely lost the ability to work. And then of course, control. So you're handing off all of your data, all of your passwords, all of your financial information. You're handing this all to X company who is telling you it's absolutely safe and we won't touch it, which is fantastic. But unfortunately, you're kind of within their parameters of what their systems are capable of. And you're also within their parameters of how much you're allotted to store. And so with that comes a few more limitations, but of course, most companies try to negate that as much as possible. So then we get into the biggest problem of cloud computing, the one that we're going to be focusing on today, and that's latency. The fact of the matter is that here in Knoxville, Tennessee, whenever I ask my Apple device to send a notification somewhere or to run a math problem for me, it's more than likely traveling all the way to a data center in California and then coming back to me. And this entire process takes place in maybe 3 to 4 seconds. Really, really impressive. Really, really incredible. But it took us a lot to get to the point where we could do that, and we're kind of stuck. We're kind of stuck at that latency point. And thus, that brings in the solution of edge computing. So what is edge computing? Edge computing is the practice of capturing, sorting, processing, and analyzing data near the client where the data is generated instead of centralized data processing warehouse. Once again, a lot of words, but basically all this means is that rather than having the data sets somewhere else and having it feed back to me, it means that I'm having these data sets and these computer resources, most importantly, as close as humanly possible to me. Now, this, of course, has to do with having, once again, on-site data sets, on-site servers, and having all of these things back on site and having to do all of that infrastructure up on front. And then we've kind of lost all of the advantages of cloud computing that it solved for us, right? So instead, what we're talking about today is instead moving offshore facilities, rather not moving them, but leaving the larger facilities where they are and branching them off into smaller subset facilities that are closer to large infrastructure cities with a lot going on, and maybe closer to pretty much everyone. And instead of one company having to pay exuberance amount of money to be capable of moving and creating brand new sites all over the globe, instead, the discussion is being had about having a third-party company who builds a giant warehouse, say here in the middle of Knoxville, that's full of servers, full of hardware, full of firewalls, and lots of security. And then they call the big companies and say, hey, we have allotted resources. Would you like to rent out a space in this? And then all of a sudden we have, 5 or 6, 10, maybe 20 giant companies all living within the same building. But the important part is that it's right next to you. All of a sudden, we see that delay cut down immensely just by cutting down the number of miles away from it we are. And so one of the ways I kind of explain how this works is, if you're familiar with how an octopus works, a lot of people say that they have 9 brains because they have a larger cluster of nerves inside of each one of their tentacles, and then an even larger one inside of their head. And so one way of thinking about this is that the octopus does have 9 brains, but really it's all part of the central core nervous system. And as a result, each individual tentacle can make a decision pretty much independently. If a predator is coming toward it, it can immediately make a decision to move out of the way or to run away without having to send the data all the way up to the brain and back to the tentacle, which could save their life in that moment. And I love this analogy because of the reason why they're built that way, and the fact that we're kind of using it for the same use cases. So before we get too deep into that, big data. So this was kind of a fun term that I found recently, but I really liked it for how it explains the reason why we can't just have all of these things inside of each individual business. We can't just go back to building out servers, and that's because of the data sets and the computations that we're doing today are so enormous. With this came the idea of the 4 V's. So first and foremost, we have volume, the amount of data collected from a variety of resources. The amount of data that we keep from business to business, and especially even in our personal lives, is growing immensely. And the further we go, more and more of it is being created. And as we sit today, there is a finite amount of hard drive space, a finite amount of solid state space. And as we create more data, we're going to have to create more space for this data to live in. And the amount of data that even a small company like ours contains, holds, and uses is far too much to be kept here on site with us. Hence why it has to be offshore, and it has to for nearly all companies these days. Second comes velocity, the rate at which data is being processed. On top of a quantity of data, you have to process this data. People are going to request this data and have it come back to them. People are going to ask for it to do certain things, perform certain tasks. And the speed at which this can be accomplished with the resources available to an individual business is really difficult to achieve. Whereas whenever we're talking about cloud computing facilities and large data warehouses, they're able to invest into the material that they need in order to run these things at the speed that they need it. And so that's one of the biggest things, is that even if you do have the space for it, you still have to be able to process it. And so variety, different types of formats of data that are transferring across the system. So this is important because we're not just talking about large blockchains of information. We're talking about different sets of informations, people's names, people's information, perhaps financial information, perhaps it's healthcare information, or maps and GPS tracking, all completely different kinds of data set in the way that it's stored, in the way that it's handled, and most importantly, the way it needs to be accessed. Some of these things, if they're not accessed at a high enough rate or quick enough, it could be the difference between life or death, how quickly you can get to this information, for some people's cases. And so last and definitely the funnest word on this one is veracity. The ability of your data tools and analysis to separate poor quality and high quality data. And so whenever we're growing in this world of analytics, where needing good information is so important, and as I talked about before, we kind of have limited room to keep all of this data. And so whenever we're talking about that, we really need to be capable of discerning kind of what's trash and what's something we need to keep. And once again, these large facilities just have the resources capable of throwing certain things to the wayside, pulling certain things out, and also doing this as you're asking it for it to be done, which is all really, really important. These four things don't necessarily encompass everything that computations and data needs to be done, but I think it really encapsulates just raw stored data and really how much this is affecting our world today and how much bigger it's getting. And so at this point, about a little less than halfway through the webinar, you might be asking yourself, what does all this have to do with 5G? Why all of a sudden is edge computing being brought up as almost a buzzword term whenever in the midst of all the 5G craze, whenever during this entire webinar presentation up to this point, I haven't even had to use the term. The fact of the matter is that edge computing has existed for quite a while. And there's a lot of resources, a lot of companies, in a lot of places where it's already being utilized. Unfortunately, the fact of the matter is that whenever you're talking about the latency difference of moving a facility from one place to another, it's really the gains that you get out of it are pretty small. And that's because we've always had limitations on how quickly data travels. Before 5G, we really, outside experimental environments, were kind of capped out at a gig. And more importantly than speed, and what edge computing is actually solving is latency. Even with that gigabit speed, we're still seeing a latency time that was similar to internet speeds of 100, 300 megabytes down. And so now the biggest thing that everybody's talking about with 5G is latency timing. If you moved a facility closer to a company and you were still using, let's say, fiber to connect those 2 points, even though the mile distance between those two places has cut down the latency time by, say, 30 milliseconds, just throwing out a number, your fiber line that's moving from that data center to your location is still capped off at, say, 60 milliseconds of latency time. So you're probably shaving off a little bit of time, but it's not just straight subtraction. So I think the gains kind of outweighed the need kind of wasn't fulfilled in that situation for the use cases that we're going to get into a little later. And so with this comes the ability to move large amounts of data with nearly no delay. Because we're able to move these local data centers closer to where we are and closer to our IoT devices and travel between these two things using 5G's network. The whole idea behind this movement, I feel, is we're all trying to get closer to that mythological 0 millisecond delay. And Although I don't know if we'll ever actually reach that. I think it's kind of a paradoxical number. It's always going to take something, an amount of time to get somewhere. We can get really, really close to it using these two things. And that's why the hype has been so much about these things, because we've been trying to cut down that delay for so many applications. And in today's world, we're finally seeing use cases that can utilize all of this power. But of course, we've gotten kind of set back by our delay times. 5G is going to make huge strides in these areas, but unfortunately, since we're still kind of stuck at that 8 millisecond limit for latency, we still need a little bit more to get us where we need to be. And that's what edge computing is going to do for us, is hopefully get us that little bit more. We still have a ways to go in really testing this and putting it through the paces in real life environments, and seeing really how much time we can shave off before putting it in situations where we're going to be using this. Because often whenever you need sub 8 millisecond latency time, the things that you're doing are going to be really mission critical. And it can be very nerve-wracking to trust all of these systems all at once thrown into the field. Whenever we're still kind of testing it, we're still kind of feeling it out. And of course, these ridiculously low latency times with 5G really aren't going to come about until we see the rise of millimeter wave taking place in wider areas and can cover a wider area. And I think whenever that starts to become more normal and we're able to actually utilize the full spectrum of what 5G is capable of, that's whenever the need for edge computing is going to arise. And we're going to need to move these data centers closer, because today, even just having an antenna mounted on the roof of a vehicle and having the cabling coming down to a modem that's receiving 5G signal, that little bit of strand of cable, at the most maybe 10 feet, can cause enormous delays in the travel time for that connection. So even though you're getting a much higher quality, much lower latency connection, you're actually not seeing the benefits of it because of how much you've lost just in cabling, which I think is really, really incredible. And so, excuse me, with this comes, of course, where are we going to see these things emerge? First and foremost, maybe an obvious one, healthcare, telehealth, and of course, robotic surgery. So imagine a world where a surgeon can work from home. That would be incredible. A surgeon, especially whenever they're doing these robotic surgeries, has to be very quick on their feet and has to be able to react to something happening quickly. Of course, these types of procedures are pretty regimented, and you always have someone else there on hand. But say you're in a situation where the best doctor for a given problem is halfway across the world and they're not able to get to you, but they have the time available to see you. It's just that neither one of you have the time to travel. If we can get these latency times where we want them, and if we can use 5G to move this data and also move the data and the computations and the resources closer to the source, we might be able to legitimately do really mission critical things like this on the fly or at a distance. So that's, I think, one of the first things that comes to mind whenever you think about healthcare. But the other thing is actually health databases. So we really don't see it. I haven't seen it too much, but there's plenty of them out there of cloud computing hospital databases. And so in the event that a hospital loses an internet connection, these sources all have backups, of course. But in the event where something like that happened and they did lose their connection to the outside world, if they still had a connection to that edge computing facility, despite the fact that there was an outage somewhere else, they could still have full control, not only to see all of their patient information, but also still be able to edit and make changes to all of that patient information, which is really, really incredible. And so we see that today in healthcare for sure, with servers on site and things like that. But with that comes the limitations that we talked about earlier that you run into, that you have to use cloud computing to kind of hybrid work around. So this is definitely going to be a place where we're going to see an impact.
And Jacob, just to touch on your first point there, it's not uncommon at all for people to travel for medical procedures right now, right? I mean, that's a really common thing. I know someone who had to go to Germany for a medical procedure, especially if you're talking like experimental things or certain treatments are maybe allowed in one country but aren't in another, or something like that, right? So that's a super common application that's going to have huge implementation, or huge benefits to healthcare in general.
Yeah, absolutely. I think edge computing and 5G, these two things are going to have to work together in order to accomplish that. And we're probably not going to see it for still a little while. Mm-hmm. But whenever it's readily available and we're able to do these things, I think it's going to become extremely commonplace. And it's going to be used all the time, for sure. I think one of the closer changes we're going to see in the next few years, and you kind of already see, is going to be those health database changes, for sure. Mm-hmm. All right. And then manufacturing. I feel like this one is a lot of what people think about, the giant automated robot arms that are moving car parts off of one conveyor belt and onto the other and then welding it down. Really, really awesome stuff. And so with that is automation, of course. And automation is definitely going to be one of the fields that gets impacted the most by this, because, of course, having those low latency times, being able to give orders on the fly to a machine that's building something is going to be really, really important. And of course, having that machine be able to have quick access to all of its orders at any given moment is going to be really important. But I think the largest change that's going to happen is that a lot of these manufacturing facilities and these IoT devices that are running these giant machines are really good at taking orders, and they're really good at keeping those orders and continuing to do one thing over and over again. But I think we sometimes forget what happens if those orders need to change. What happens if a part in the procedure gets changed? Maybe a particular manufacturer of a piece you were using to build a certain product is no longer available, and you have to find another manufacturer for that product. And that particular product is maybe a little bit larger or a little bit smaller than what you have. So how do you tell your machines that that piece needs to be grabbed, a little smaller or a little larger? And I think because of that, we're going to see the biggest impact happen in quick changes being made. Because today you'd have to maybe plug into that device with a computer and rewrite its code or change a variable. Maybe it has an interface that uses the internet to connect to, where you can make a change like that. But it's really not a small thing to stop these things in their tracks and then change entirely how they're doing things, especially if because of that one little change, you have to change most steps of the process to make sure that there's just these little things that happen. And so I think that's going to be really, really incredible to be able to make changes on the fly. It's going to save people money. It's going to save people time. And also, we're going to be less concerned about little changes needing to be made. Because if something happens, or if you lose a part, or if you're having to change something up, it's really easy to just go in, make that change, and then the machines start running the way they're supposed to.
And the automation aspect of it too is really interesting, because I mean it's you're saying about making those changes quickly. Well, at a certain point, new IoT devices will come on or will emerge and just be like an additional AI for it, right? And that'll take bandwidth, and that's all expanded with 5G and is enabled with 5G. But we're talking, I think, in the next 10 or 20 years about the machines being able to notice and make that change themselves, right? Or if a machine goes offline, the factory server can detect and re-online it without any human intervention. And I don't know, it's a really exciting field, because it's difficult to even imagine, what it's going to look like, but it's all enabled because of edge computing and 5G.
Yeah, I'm actually really glad you brought that up, because like I said earlier, these machines are really good at taking orders, right? Simple step-by-step processes: move this, slide this, pick this up. But a lot of AI machinery is getting a lot more sophisticated. We're just not really able to fit it into these devices. And of course, cloud computing could solve that problem. But whenever you're needing an AI system to make changes on the fly as a part is, coming down a conveyor belt, maybe this fast, if it delays even a little bit in noticing that it's different, it can completely mess up the assembly line. And so having an edge computing facility right next to it, or maybe even on-prem, you'll see it being able to make that decision like that. Oh, that bolt's a little smaller. I'm going to grab it differently, which is going to be really, really incredible.
Yeah, absolutely. For any of you guys watching that do any AI building, there's your first use case for edge computing.
Absolutely. And so the next place you're going to see it, and I find this one really, really cool, because I didn't think of it right off the bat before I started doing a whole bunch of research into this, is finance. Finance is actually going to be heavily affected by this change, because as we talked about, these data sets are growing and growing and growing. And especially for financial officials, the number sets are getting bigger and bigger and bigger. We're not just taking care of larger entities and taking care of larger companies, we're also caring about more of that data. We're running more of those analytics. And so right now, in a lot of cases, maybe somebody has to go through a spreadsheet and look at line by line, add this, multiply this, subtract this, move this. Whereas if you had an autonomous database somewhere off-prem that you could say, I need analytics for this entire sheet based off of what the columns say, and I need it to be done like this, and hit enter, and you have your data like that. That's an enormous amount of computation that can be done from a device as small as any other smart device you have, or as small as the laptop on your desk, without any latency, without having to wait on any amount of time, because all of those resources are at your fingertips right next to you. And then, of course, I don't think we can really talk about 5G and edge computing without bringing up autonomous vehicles. Absolutely the coolest application for edge computing and for 5G. So in an autonomous vehicle, it needs to be capable of making split-second decisions. In a lot of IoT use cases, the difference between my Alexa being able to tell me the weather outside and having to take a couple of seconds to do that, in a vehicle having to take a couple of seconds to notice that another vehicle is coming toward it, or maybe just pulled out in front of it going 100 miles an hour, could be the difference between life or death. And so we have to either cram all of this computer power into a vehicle, or we have to rely on cloud computing, which there's going to be delays for, which means that having a computer cruise on the highway will probably be fine, but having it do city driving, stop and go, noticing traffic lights, all of these things that our brains are really capable of doing really well on the fly, an autonomous vehicle still isn't quite to the point where it can do all of those things. And so being able to utilize edge computing facilities, and of course, connecting a vehicle via 5G connection, which has very low latency, we're going to be able to get to that point where a car could pull out in front of you, or maybe a car is about to T-bone you, and your vehicle isn't just seeing that, predicting how it's going to happen, and making a move accordingly, but maybe it's also checking databases of other vehicles in the area. It notices that another vehicle on the same road as you is speeding towards you, and it's already stopped you. And here you are stopped in the middle of the highway going, why didn't my car just stop? And then another vehicle boulders out in front of you because it's already made the decision to save you. So really, really, really excellent use case. And as I put, a necessity for this use case if we want it to do everything it needs to be capable of.
Yeah, and there's some cool aspects of 5G that get interesting as well. Like, 5G is obviously a lot more secure, and I know security was one of the big things whenever they first started talking about self-driving cars, right? It's like, what if someone hacks it and just slams the brakes or whatever? So that's definitely one of the benefits that 5G is going to bring to it.
Absolutely, and something I really haven't touched on too much is that with edge computing, you can also have shelled-off networks. So this is a facility that's just connected to its IoT endpoints, and then it has one connection out into the internet, and they can put a ridiculous amount of security between the internet and that facility, which means you're getting the security benefits of 5G, but you're also getting a lot more, I guess you could say, brick and mortar security. Actual physical machines that are keeping all of those things secure. And I think that's going to be really, really crucial going forward as well for pretty much all the use cases we've shown today.
Right, for sure. So first question that we got, Jacob, do we need to build more small cells to have better edge computing to work? So I think that sort of fits in that diagram we had before, right?
Yeah. You think they're talking about small cells as in like the local data centers, or cells in terms of connectivity?
I do not know, but if it's data center, yes. What would you say in regards to the second half of that?
Yeah, I was going to say, I guess I can kind of answer both. We're definitely going to have more data facilities, no doubt, in order to be able to accomplish this. More cells, I would say we kind of already need more infrastructure for 5G, regardless of edge computing. We're seeing that with the heat maps from the carriers and things like that. We're needing to branch out, and we're needing to cover a wider area, especially when it comes to mid and high band that don't cover as large of an area as low band does. So I'd say we're already in the process of that, but I would say almost certainly, because we're going to have huge data transfers moving from one place to another, and I think we're going to need to have dedicated lines to be capable to do this.
Very nice. So second question, I know we had a lot of talk about, like this is coming, right? So when's that going to happen? What's the timeline for that look like?
Oh gosh, I mean, there are so many. Edge computing is such an umbrella term that really some places are already doing it. Some places already have on-prem servers and computations going, but a lot of places like that aren't necessarily doing it for the latency difference, I would say. I'm sure there are some, but they're not common by any means. Whenever we're talking about the kind of Blade Runner-esque applications and the futurescaping and things like that, probably going to see that occur closer to whenever millimeter wave is a more viable solution, and we're able to utilize the latency that it provides. Because, like I said, we're trying to get close to that mythological 0 millisecond, that instant response time. And right now, I think high band is the closest to doing that. And then at that point, edge computing is going to be a necessity.
Okay, awesome. Good answer. This next one, are there applications for every industry? I can answer that yes. Jacob, if you want to expand on that.
Yes, you're absolutely correct. I think what's so cool about this is that it won't just become, it isn't just that there is an optional application, it's that it's going to become a necessity, and eventually we're going to be in a world where you don't even really think about it or know we have it. Because the closer we move these data sets to us, the more we do things like this. As I said before, cloud computing is in every company today, in ways that maybe they don't even realize that it is. And so in that same vein, as we need faster response times, as we need more data, that is going to make that switch to where we're going to see edge computing be the need. And yeah.
Awesome. So this last one is full disclosure, my question, and you already answered the first half of it. But is this something every business needs? And if so, what can businesses do to prepare for this technology?
Yeah, like I said, I think it will become a necessity the more we grow and the more things we're capable of, which is really, really exciting. Is there anything that you can do today? For some businesses, maybe, if you're a facility that is running into issues with latency, I'm sure you've probably found this solution, because that's kind of how niche it is right now. We're not seeing it being used to the fullest of the capabilities that we're going to see it in the future, and we're not seeing these data centers pop up everywhere to be able to be useful. I would say if you're not doing anything extremely computationally heavy, I wouldn't worry too much about looking into it now. I think what's going to actually happen is these companies that use cloud computing are actually going to come to you, and they're going to say, we've made upgrades to our system, we've done this, we've done that, and somewhere in the paperwork, somewhere in the speech, they're going to use the term edge computing. And now, after this webinar, you're going to know what that means and know how significant of a change that's going to be for that particular cloud computing company that you're using today.
Absolutely. And one thing I just thought of whenever you said that, if you're looking at future proofing and getting your organization ready for cloud computing, investing in 5G is a great way to start, right? Because you need to have that quick response time to be able to take full use of that. So whether it's getting 5G devices, there's a lot of exciting devices coming out. I think I've seen even just this month. So it's coming out quicker and quicker, and there's a lot more devices than there was, a month or two ago. So looking at that, again, I would take advantage of that free 5G expert consultation. If you're looking to determine whether 5G is ready for you or not, a lot of the devices, the routers and antenna that are up there can work for LTE and 5G. So even if you don't have it in your area yet, you can buy something that you can always upgrade with just putting a different SIM card in there, right? So I don't know if you have anything to add to that, Jacob, but that was just a thought that popped after you said that.
No, you're absolutely correct. I don't think I have anything to add to that. That was great.